Hello everyone. In this video, let's solve a numerical problem on the concept of relief displacement. The relief displacement is a kind of a phenomena, or it is that concept is seen in the vertical photographs. Usually, relief displacement is the lateral displacement. It's kind of a shift actually. It is that displacement in the position of an image on the photograph of a ground object. Generally, this is seen on the elevated objects like the factory chimney or tower. So there is a uh, the derivation for an equation, and it justifies the amount of relief displacement seen on the vertical photographs. It is useful in determination of height of various objects such as buildings, poles, or chimneys from referring its radial distance or displacement from the photographs. Uh, let's directly look into the numerical problem. The problem statement is something like this. The images x and y of the base and top respectively of a factory chimney 150-meter high are observed in a truly vertical aerial photograph of scale 1 equals to 10,000. Determine the position of x given that y is 70 millimeters from the principal point of the photograph. Take the focal length of the camera to be 125 millimeters and assume the chimney to be at datum level. So let's start writing the diagram for this. So this would be kind of a approximated representation of the given problem statement. The capital XY is a chimney. X is the bottom and Y is the top of that chimney. And this level is a photographic plane. This is that photograph where we would generally observe small x and small y. So this is that principal level. P is kind of a exposure station. This depth is the focal length, which is 125 millimeters. This radial distance to the bottom seen on the photograph is known to us, which is 70 millimeters, and x is directly on the datum. So this line represents the datum. The height of the chimney in reality is known to us, which is about 150 meters. Okay, so there are two ways to solve this numerical problem. One is just by directly referring to the displacement formula, which is a derived formula which says something related to the R naught and R values from the photograph. The other method is directly by considering the similar triangles. Let's solve this. Uh, so we know that the scale equals to F divided by H minus H1. So this capital H is the flying height, whereas this H1 is the elevation of that position or that point at which the chimney is located. Now, the chimney is exactly located at the datum. So, the H1 value seems to be 0 in that case. So, the scale is 1 divided by 10,000, which is equals to 125 divided by H minus H1. H1 is 0. So, we would be expecting the value of capital H, which is a flying height, in terms of millimeters basically, because the numerator is in terms of millimeters. Upon the conversion, we get a value of 1250 meters, which is the capital H value. Okay, now let me redraw the diagram by considering some sets of triangles here. So x, y are the same old radial distances seen on the photograph. F is a focal length. The flying height is 1250 meters, which is exactly 1.250 kilometers, and the height of the chimney is 150 meters. So the chimney is located at a radial distance of r meters from this line, which is a kind of principal axis. Okay, so please observe the triangles here. I'm referring to a triangle which consists of x as the base and the height is f, and the other triangle which has h as 1250 meters as the height and base equals to r. Therefore, it is possible for us to write f divided by x equals to 1250 meters divided by r. Now, except r, everything else is known to us. So f is 125 divided by 1000. Millimeter is converted into meters. 70 millimeters, again it is converted to the meters. 1250 is already in terms of meters divided by r. Upon simplification, the value of r would be 700 meters. Now r is known to us, so this is that r, and fortunately this top radial distance is also r. So let's concentrate on the other set of similar triangles. And then, it is also possible for us to write one more statement saying that f divided by, so this f divided by, this is that, the radial distance y, which is equals to, this is that height to which the base is occupied. So 1250 minus 150, we are referring to this line where the dimension is r, the height is 1250 minus 150. So 1250 minus 150 divided by r. Now r is 700 meters, which is calculated from the previous calculations. Now y is a kind of a unknown value now. So y is calculated. So upon further simplification, y is about 0.07955 meters, or the y value calculated is about 79.55 millimeters. If you remember, the value of x is 70 millimeters, y is greater than x, and this thumb rule could be used in identifying the correct value. Thank you.